In this lesson, we are going to learn how to expand logarithms and write logarithms as expressions as single logarithms. Sorry about that. So we need to review the properties of exponents prior to working through these problems. So the product rule, remember a product is what you get when you multiply two numbers together. So the product rule says that when you multiply your bases, you add the exponents together. Quotient, remember a quotient is what you get when you divide two numbers together. So when you divide your bases, you subtract the exponents. And then the power of a power rule. This rule states that when you have an exponent inside and outside of a set of parentheses, then you will multiply those exponents together. So we're going to keep those rules in mind. We also need to remember how to translate from exponential form to radical form. So this is used when you've got a base with an exponent that's a fraction, and it'll help us make it into a radical or vice versa, whichever form we're wanting to use. So in this section, they're going to give us this radical form, and we're going to need to put it in that exponential form so we can write it correctly. So anytime that you've got, let's say, 2 to the third power, the 2 would be considered your base, and that 3 would be considered your exponent. So when you have an exponent that's a fraction, we break it apart to be power over root, okay? So the way I remember which one is where is power. I think of like God being the almighty power, so he's going to be up top. And then roots grow on the ground, so they're going to be on bottom. If you don't like that rule, then you don't really need to use it. I'm not trying to push my beliefs on anybody, but that's how I remember it. So here, radical form, in this little crease of the radical here, we've got root. All right, that's another word that we also use as index. Index is this number here. And if it's not written, it is an understood 2. All right, so if I just had this symbol right here, that crease right there would have an understood 2 right there. And our base would be right here, and then the power is going to be the exponent of that base. All right, so let's go ahead and dive on in here. The directions are going to ask us to use the properties of exponents to expand each expression. So when we expand this, we're going to want to give everything this logarithm and the base of 3. So when we look, we notice that between the 7 and x, since they're right next to each other, that means that they are multiplying, okay? Now, since logarithms are exponents, we need to use our exponent rules. Well, when you multiply your bases, you're supposed to add those exponents together. So when we break this apart to be in logarithmic form, we're going to write our log base 3 twice because we've got a 7 and an x multiplying together. So since there's only 2 things multiplying, we'll write 2 of them. Now, if let's say this was a 7xy, that would be 3 things, so I would want to write 3 log base 3's. And so this one is going to get our 7, and this one is going to get our x. So we're just going to put them in order that they came in from left to right. And then since we're multiplying here, when we break it apart and expand it to be 2 different logarithms, we're going to add those logarithms together. So again, when you multiply your bases, you add your exponents. So here, log base b, and then we've got 2 over y. So again, I'm going to write my log base b of 2 and my log base b of y. And since I'm dividing these two, that 2 and that y, well, then that's going to be our quotient rule. When you divide your bases, you're supposed to subtract the exponents. So since these 2 are my exponents here, I'm actually going to be subtracting them when I break them apart to be my 2 different logarithms. And then our power of a power rule states that when you have an exponent inside and outside the parentheses, you will multiply those exponents together. So when we have this y and it's got an exponent up here with that 4, what we're going to do is we're going to take that 4 and we're going to put it out in front of our log base 5. Okay? So I write my log base 5 of y, and then that 4 is going to be in front. So if I had like a z to the 3 behind it, then I would put plus, and then I would have my 3 log base 5 of z. So that's why there's only a log written here one time, is because y wasn't multiplying or dividing. It just had that exponent of 4 with it. And so here on number 8, this is where we're going to need to do our translation from that radical form into our exponential form. We're going to want to rewrite this using an exponent. So we need to have all components here. So z is my base, and then I've got my 3 for my root, and I went ahead and wrote in this 1 for my power because I need to know what all 3 of those are when I plug them into my exponential form. So I'm going to rewrite this as log, and then I have a z, and then 1 over 3 because it's power over root. So z to the 1 over 3. Okay? And notice that there isn't a base here. Anytime you don't have a base written in a problem, it's an understood 10 down there. You don't have to write it if you don't want to. I'm just letting you know that that would be a 10 there. So to put this in our correct expanded form, then we're going to put that 1 over 3 in front of our log, and we're going to have our z here. So you could either write it this way, or you could write it with that base 10 if you want to. But since the 10 is understood, you don't have to write it. All right, so now number 10, we have our x to the 3 times z squared. So since we're multiplying up here, we're going to add our log base 7s. So I've got log base 7, got an x to the 3 and a z squared, and I'm going to be adding them because they were multiplying up here. So now in order to fully write them in this expanded form, we want to take our exponents and put them out in the front of my logarithms. So I have 3 log base 7x plus 2 log base 7z. And that would be our final answer. And when you look at problem number 12, we're going to have to do some more translating here because I've got that radical form in there and I don't want to translate that. I need to have that into that exponential form so I can actually translate it correctly. So I'm going to rewrite this as log base b, x to the 3, z to the 1 over 3. Now we already did this problem up here when it was a cubed root of z. So if you need help doing that translation, how I got that z to the 1 over 3, then rewind this video and look back at number 8. So now I'm going to break this apart, and I'm going to write log base b 2 times because I've got 2 things here that are multiplying, dividing, and so on. So I've got my log b x to the 3 plus log b z to the 1 over 3. Now I take their exponents and I move them out in front of my logs. So I've got 3 log bx plus 1 over 3 log bz. And that would be our final answer there. So now let's do a couple more. So here I've got log base 5 of 3 divided by xy. So I've got 3 different things. I've got a 3, an x, and a y. So I'm going to write my log base 5 3 times. Okay? So now I've got a 3, I've got an x, and I have a y. This 3 is on top. It's going to just say log base 5 3. But then I'm moving this x, it's down at the bottom, so if I'm going to be dividing that 3 by x, then I'm going to have subtraction. Remember, when you divide your bases, you subtract your exponents. And here, this y is also being divided by that 3. I'm sorry, that 3 is being divided by that y. I said that backwards. So we're also going to have subtraction here. So because both of these are down at the bottom, we're going to give both of them a negative. Okay? There are no exponents we need to move here. The only other thing that we could do is we could have our log base 5, 3, and we could factor out a negative in here to be log base 5x plus log base 5y. Because this negative out front really means that anything that comes after this is going to be in the denominator. And then since this x and y are multiplying, then they're going to be adding inside of that set of parentheses. Now, I myself would accept either one of these answers, so if you gave me this top one, then that's perfectly fine. All right, so now for number 16, I'm going to go ahead and translate my radical first. So if I have the square root of y, this root is understood to be a 2 and my exponent is 1. So when I translate it, I'm going to have y to the power over root, so 1 over 2. So I'm going to rewrite the whole thing so I don't get confused. And now I'm going to write my log base 4 3 times because I've got an x, a y, and a z. Now, these x and y, they're both multiplying by each other, so I'm going to put a plus sign in between them. And then we're dividing by that z squared, so I'm going to put subtraction there because we're moving that guy down to the bottom. So now all of our exponents are going to be moved in front of our problem, of our logs. So I've got 3 log base 4x plus 1/2 log base 4y minus 2 log base 4z. So now we're going to learn how to go the other way. So instead of expanding these logarithms, they're actually already going to be in expanded form, and we're going to want to condense them into one single logarithm. So that means we're going to want to write this log base 5 just one time. And remember the rule, we're subtracting these two exponents here. So when we subtract our exponents, we divide our bases. So I have x divided by y. Okay? So here I have log base b, and I've got an x times z. You can either put that little dot in between them, or you can just write them side by side. It doesn't really matter. But notice that there was a 3 in front of our log problem there. So we need to bring that up to be the exponent of our x. And if you wanted to bring a little 1 in front of that z, you could, because there's technically a 1 in front of that log, but you don't have to. And that's our answer there. So now here, this one's going to be a little bit trickier. We're going to write our log base b one time, and I've got an x to the 1/2, but notice that this minus sign means we're going to be dividing z to the 3rd, because I take this 3 and it becomes my exponent of my z, and it was x to the 1/2 because I took that 1/2 and moved it up to be the exponent of my x. But the tricky part is that we need to still translate that x to the 1/2 into radical form. So when I do that, I'm going to be left with log base b of the square root of x over z to the 3rd. The way I got that is x to the power over root. So my base goes in here, power is 1, root is 2. You can put the 1 and 2 there if you want to, but since they are both understood numbers, you do not have to. Okay, so next we're going to do number 26. And you can think of this a couple of different ways, but the way I like to think of it is just to go ahead and distribute this -1 into each of them. So we've got 2 log base 5 of x minus 3 log base 5 of y minus, because a negative times a positive is a negative, log base 5 of z. So now everything that's got an exponent is going to move up as an exponent in front of here. So every time it's got a number in front, we move it up as the exponent. So I now have log base 5x squared minus log base 5y to the third minus log base 5z. All right, so now I write my log base 5 one time. My x squared is up here on top. Minus means we're going to the bottom, and I have my y to the third. Minus means we're going to the bottom, and we're putting our z on the bottom. And just make sure you've got those in alphabetical order. And then finally, here, I've got my 1 over 3 that I'm going to bring over as my exponent of my y, and my 4 that I'm going to bring over as my exponent of my z. So I have log base b of x minus log base b of y to the 1/3 minus log base b of z to the 4. So now I'm going to go a little bit step further, and I'm going to translate that into my radical form. So I would have log base b x minus log base b, and this would be the cube root of y. It does matter, the cube root, that 3 has to go in that little crease right here. And you do have to write it, because if you don't write that 3, then it's just an understood 2 there, and that doesn't work. Exponent of 1 minus log base b z to the 4. So now we can go ahead and write this as a single logarithm. Log base b. So my x is going to go on top, and then since it's minus, that means we're going to the bottom, and we're going to put that cube root of y on the bottom. Then negative, that minus sign right there means we're going to the bottom again, and I'm going to put my z4 here. Now this z to the 4 is going to go in front of my radical sign here. Okay, so I'm not going to put it behind there. Anytime you've got a radical, the radical is going to go in the end, and we're going to put our z to the 4th in front. Okay, I hope that this video has helped you, and I wish you the best of luck.